Hello, my name is Lauren Estes, and I'm an undergrad studying civil and environmental engineering. I've been working on an environmental engineering project under Dr. Nancy Love and Dr. Krista Wigginton called Nutrient Recovery through Urine Separation. This is a very large project that encompasses several entities: the Hampton Roads Sanitation District in Virginia, the Rich Earth Institute in Vermont, the University at Buffalo in New York, and of course, the University of Michigan. Urine is just a small volume of municipal wastewater, but it holds high concentrations of the nutrients, such as nitrogen, phosphorus, and potassium. These nutrients make urine a good potential source for sustainable fertilizer. It also contains a high percentage of micropollutants, such as pharmaceuticals. By diverting urine from general wastewater, we can reduce the nutrient load to surface water, which can cause harmful algal blooms and eutrophication. Separating urine can also help to reduce the amount of pharmaceuticals entering the wastewater stream so they could perhaps be treated more efficiently. The phosphorus in urine can also be used as a renewable supplement to phosphorus mined for fertilizer. One last benefit to source separation is the reduction in water that would have been used to flush the urine to a wastewater treatment plant. There are, of course, a few practical issues and safety concerns that arise with the reuse of urine. These include the fate of the biological and pharmaceutical contaminants within urine. Our goal is to provide guidelines to address these issues and a holistic analysis of nutrients, pharmaceuticals, and microorganisms from urine collection through treatment, application, and crop harvest. This will allow us to evaluate the risk regarding contaminants and determine the efficacy of urine and urine-derived products as agricultural fertilizers. The particular urine-derived product that we tested as fertilizer is known as struvite, which is a naturally occurring precipitate of aged urine that can be artificially induced by adding magnesium and adjusting the urine's pH. This project is a very collaborative effort. The urine is first collected and stored in Vermont by the Rich Earth Institute, a nonprofit organization. There, the field trials are carried out, and plots growing lettuce and carrots have pasteurized urine, struvite, and commercial fertilizer applied, with one control plot that doesn't have any applied fertilizer. The Hampton Roads Sanitation District office building in Virginia is a demonstration of collecting source-separated urine and will use the urine to produce struvite on site. Samples from the field and the office are sent to the University at Buffalo in New York for pharmaceutical analyses and to the University of Michigan for nutrient and biological analyses. One of my favorite things about this project is its size. It has been so interesting to see the national scale cooperation between these groups. Being involved in something like this is such a unique opportunity, and I am very happy to have been able to contribute. My particular role in this project is to look at the fate of nutrients from collection through treatment and application, as well as their concentration in the crop runoff water that would join the groundwater table. The runoff water is collected in lysimeters, the blue containers surrounding the crops shown here. The treatment for the urine applied to the field is a pasteurization step, heating the urine up to a certain temperature for a set time and then cooling it back down. We hope to establish whether this step is enough to eliminate any pathogenic or pharmaceutical contamination in the urine. The particular nutrients that I test for are nitrogen, phosphorus, ammonia, magnesium, potassium, and total organic carbon. The tests for nitrogen and ammonia help to determine what form the nitrogen is taking. Nitrogen as nitrate is more accessible to plants than it is in the ammonia form, so it's important for us to identify the nitrogen species that is predominant. Fertilizers are categorized according to their NPK value, which is the ratio of nitrogen to phosphorus to potassium. So checking the NPK value of the urine and struvite to that of industrial fertilizer can indicate how comparable all of these fertilizers are. Magnesium is monitored to make sure the conversion of aged urine to struvite is efficient. The final nutrient monitored is total organic carbon. I have really enjoyed having this opportunity to experience a full-time research position. I worked in this lab during the year, but it's very different researching part-time versus full-time. This has given me a lot of insight into graduate school. It's been very helpful to ask people about the application process and to hear about what grad life is generally like. I know that this summer has helped me to solidify my decision to pursue a master's degree after undergrad. I want to thank everyone that I've worked with this summer for an amazing experience and the SURE program for allowing me to have this opportunity.